So this is how the analysis works. We have a model, which is the core of what we are doing, where we are analyzing. We're going to analyze different options, but we need to configure the model to represent the different improvements we could do in our system. So we have a table here, which we will see in a minute, where we can change things according to those improvements. This is the first thing we do. Then we run the model. We can run it in different modes. We'll see it. And then we have output results. So with these results, we can see how the system performed, and we can decide to go back to the configuration, change something else, and run the model again, and do that in a iterative way, so that we end up with something that satisfies us, and we have something that we can expect from the real system when we do the changes in that system that we did in our model. So let's see the model. There we go. So if you're not familiar with Simio, you don't need to be much familiar with it, because this is a model that is a device for anyone using it to just change some properties, which is how they are called in Simio, and get results. So there's no need to be an experienced or even a beginner modeler in Simio to run this model. We have, I won't get into the details about how this model has been built, or I won't get into the details of all the options you can use in Simio. I will just explain how to use the model to analyze it as if someone was an analyst, but not a Simio developer. So we have represented the bars with this triangle, this green triangle, that are changed into valves, which are the blue triangles, and they're going to move along the different stages. We see the saw here that sends the bars, once they're cut into blocks, which will be eventually valves, through the conveyors. We can have one or two depending on how we configure the model. Then they are going to the coater area, where they are processed and lots of 6 items. They are sent to the inspector. Some of them have to be reworked, and after the inspection they go to the hardener, then to the loader, where a fixture holds 4 of those blocks. There are these grinders here. We see only one, but there are 2. We'll see it in a minute. They are unloaded. Fixtures go back to the loader, and the valves go to the cleaner and finally shipped to the customer. Okay, we will see the configuration in a minute, but let's see how this is when we execute, when we run the model. So we can go to this ribbon here, to the Run tab, and we have this button, Run. If we click on it, we see that I'm going to stop it after it's run for a little while. Okay, there you go. So we have bars waiting here in the initial buffer, the input buffer of the saw. We see the saw that is processing one of these bars and cuts into blocks, and we see the blocks that have been traveling through the conveyor. Some of them are here waiting to be processed. In this case, no, the coater has finished, and we see the inspector that is inspecting. So we're emptying the coater, and then it'll go to the hardener. We can move a little bit forward the model. There you go. And now we have the hardener, which is holding some items, and we have, for example, this loader, which has 2 blocks waiting for them to be mounted onto the fixture and then sent to the grinder. And okay, we see that we have 1 item here. Sometimes we might have up to 2, because the capacity of the grinders is 2, although we only see 1. It's like as if we had 2, and then they are shipped to the customer after being cleaned. We have the input buffer to the cleaner here. So one of the advantages we have with this simulation is that we can have a look. This is not the best way to analyze how things are, but we have a first approach of how a system performs just by taking a look at it and seeing where the queues are, where we can have the more saturated, the more busy processes, and so on. Okay, and as the first approach to how things are, we have these elements here. We have the total investment. We haven't done anything regarding the improvements we can do. We have the hourly production, the total production up to now. Okay, we see the valves here. and we are still in what is called the warm-up, because when we run a model, this is not something you need to be very concerned with, because it's taken care of with the code in Simio. But if you want to analyze the system, and you remember that we started, I'm just clicked stop, and it goes to the original state, and I'm going to run it again. During a certain time, the system is empty. So we had to get rid of these first hours, days, whatever, so that we don't take into account those moments when we are going to analyze the steady state. So if we run the model, in this case, we have a warm-up of several days. Okay, we can see it here, 100 hours. Okay, so once we have those 100 hours have passed, we start recording information. But again, you don't need to be concerned with that. I can move fast, I can run the model in a faster way, just clicking in this fast forward button. I won't see how things move, okay, but I see that time, which is represented here, moves faster. I can pause it and run again, and okay, I see, for example, now that we have this run time, okay, which is 2,435.6 in a minute hours, okay, out of this total number of hours. And we see the total production during those hours and the hourly production. We can fast forward till the end, and it moves very fast. And what we have is information about the total runtime. Okay, we have these hours because that includes the warm up, but we are only recording information from the 100th hour and the next. So in total, 4,000 hours. We have this total production, this hourly production. It costs us nothing because we didn't invest any euro in our system. And the next thing we can do is go up. Sorry, I'm going to fast forward again. We want to know what the results are to decide how to invest. And the way to do that is go to the results tab, which is here.